Okay, we're recording. So I have a class passenger. I have a class airplane, which has a member and array, which is part of the standard library from C++ 11 and forward. The array holds the objects of passenger and has a size 100. It's called passengers. Everything is public for simplicity. I create an object of airplane, and now I can access airplane.passengers. This is my array. Can even look at it. This is passengers inside debugging. This is our airplane object. And this is passengers. This is the array. And there's 100 passengers here. They have nothing because we didn't fill any member. So this would be one way to have an array of passengers. Now, how about the other ways, which you've seen in the examples?
And then we would just...
Sorry?
If I can ask, so then we would, then we would just, like, for example, use a for loop to add passengers in the array.
So
or the passengers are
right
already
now
inside of
with this design, with using an array, you already have 100 objects of passengers. Like they are there. The moment you construct an airplane, you've constructed 100 passengers, because this is an array that has to fill those objects. Now, it doesn't mean that you want those, or it means that you need those. So what you usually do in such design, that you would add like an integer to keep a reference of how many passengers you have, like number of passengers. And in the constructor, for example, you would start with 0.
Okay, so then, for example, on the, okay, so then we would just increment it, for example, with a function. Each
So
time
now
that we wanted to add
so
a
now if
passenger.
you want to add a passenger, let's say add passenger, and you're passing a passenger object here. We're gonna pass it as a constant reference. What you will do is that you would access, like, this number of passengers will tell you how many you have filled in this array that you want, for example. So if so to access and the passengers at this number of passengers, it means that this is the end of it. This is where you can fill a new one now. So we'll put in the array of passengers at this index, we're going to put the new passenger, which really means that we're making a copy of this passenger we're passing here, and we are removing the passenger object that was in here and putting this instead. Because our array already has 100 passengers.
Okay, I understand.
We're just replacing it. Like when you're dealing with an array, you have to fill the 100 elements or the size of the array. You can't keep any part of it empty. So that's why we're using an integer here to keep track of how many passengers we've added. And then we are replacing an element inside the passenger. So what do we do right now after we've put this passenger inside passengers at this index?
We need to increment the count of
passengers, because we're keeping track of how many passengers we've put out of the 100 using this integer. So we need to increment the number of passengers. So the next time we add a passenger, the number of passengers would be 1, and it will fill the second element in the array.
Okay. Okay.
Now, this is one way of doing it, but you have other ways of doing it as well. Do you have a question before I continue?
Yeah, I wanted to also ask one thing, but in this one, we don't really have to go too much in detail. It's something that I thought of now that I was just wondering. Let's say also, would it be possible in the array of passengers to see if the object passenger has certain specific attributes? Let's say we make a bool function that returns 1 if the passenger does have a ticket, or 0 if the passenger doesn't have a ticket. And then we want to make a function that sorts through the array of passengers to see which ones have 1 so that they have a ticket, or which ones have a 0 so they don't have a ticket.
Okay, and what do you want to return? The count of maybe how many have a ticket?
Yeah, essentially.
Okay, so let's start with the bool part here, with the passenger part. Let's add a bool has ticket. This is what you're saying. I'm going to in the constructor of passenger. Passenger. Did I write passenger right? I don't think so. Anyway. Okay. And the constructor here, we're gonna initialize has ticket. Let's say with using the rand function. Okay, we want true or false. C++ random true false. Okay, we don't want anything complicated. Maybe at some point we will cover the like the more advanced random stuff, random generators in C++. But for now, let's stick with rand. Okay, does this work? Okay. Very bad random function for Boolean, but it should work, or does the job for now. So we're randomizing whether true or false has ticket, just to keep track of things. I'm making has ticket public, but if you want to, like, it doesn't matter. Let's make it private, and then we can write a get function. Okay. So now inside airplane here, because you have an array of all the passengers, let's say it returns an integer, count has ticket. Now you want to have a for loop that goes through every passenger. So let's start with count equal to 0 because we want to sum it up. Do you guys remember the for loop that I used last time? So this for loop is going through every passenger inside passengers array and returning a reference, constant reference to that passenger. I'm gonna write both for loops now, but just to, so let's keep things simple. So passenger now, okay. An error, but I'm not sure why. Okay, let's stick with the,
Well, I understand the concept.
yeah. Okay, just let me finish it. Passengers dot size. So passengers at I, for example, get pass ticket. Does this work? Yeah. Count plus plus and return count. So going to the airplane here. Airplane count has ticket, and this should output out of the 100 how many we have. 51.
Okay.
Now, this is not a very good example because out of those hundreds, not all of them, we have them actual passengers. So you might want to go to until you reach the number of passengers you have. And here I'm going until size, but you'd want to go until number of passengers.
Okay, so then we would replace it with the number that we were incrementing with the number of passengers. Yeah.
You would go from 0 until you reach the number of passengers you have.
Okay. Okay. Yeah, it makes sense. Thank you, sir. Would it be possible for you to post this on the OneDrive as well, if you don't mind?
Sure, I'll just copy paste it into a separate file inside this project, and you can extract it from there.
Perfect. Thank you very much, sir. It's really appreciated.
But make sure you review one of the tutorials at the beginning that we did where we covered the difference between like array like this and array of pointers.
Yeah, I have to. I'm having a bit of difficulty with that, so I definitely will. Thank you.
Yeah, because you might be asked to store the array differently. You might be asked to have a pointer to an array or an array of pointers, and each one makes everything different.
Yeah.
Okay, I'm gonna put it in a header file. This is not the right way to share code inside a project, so don't do what I'm doing right now. It's just for like to be able to pass the solution to you guys. Anyway. Okay. So anyone have any other questions, whether related to what we covered before or anything in general or polymorphism? Okay, so let's start with a simple example. Let's say we have a class employee. And let's say this has private members. I'm putting everything in one like COP file in the main function, but just to make things quick, but you should at this point understand how to separate files and headers and COP files and so on. Let's include string. Okay, let's say this guy has a name and pay rate, for example, how much they get paid. Okay, now for the public, actually this should be protected because we're dealing with inheritance here. Do you remember the difference between protected and private?
Yes.
Okay, if anyone wants me to review that, let me know. So public, in this case, let's say we have a constructor. Takes the name and the pay rate. And then we initialize everything. That's our regular constructor. And let's say we have a function that returns double, get pay rate, or get pay, not the rate. And let's say we are passing here number of hours. So how many hours this person have worked, and we want to return the pay. So let's say the implement definition of this function is number of hours times the pay rate. This will be returned. Okay, any questions so far about this simple class? It's a class employee, it has a name, it has a member double, a pay rate, and then just a simple regular constructor and a function to get the pay. We pass the number of hours, it returns number of hours times the pay rate. This is the pay rate per hour, let's say. Now we will create a class manager. This manager is an employee, so we will inherit public inheritance from employee. For the constructor, we will have a regular constructor as well. It takes a name. And it also takes pay rate double. And to initialize everything, we're gonna use the employee constructor here because we're inheriting that employee. So we're gonna pass the name and pay rate. And we don't have any extra members, so we're not initializing anything other than the employee. And we don't also have any extra members, so we're not gonna add anything, but we want to change how, like the pay of this manager. Managers gets, by default, let's say, 10,000. Okay, 10,000 is too much. 1,000 plus whatever the normal pay is. So employee pay, get pay. Okay, get pay has to have integer number of hours. So basically the difference here is that the manager, whenever we call get pay on the manager, it's going to be 1,000. That's a fixed number regardless of what this manager works of hours, plus the normal calculation of the employee pay. So it's number of hours. We're calling the get pay of employee directly, which is here. It's number of hours times pay rate. Now, let's say we have, so let's test this first. So let's create a function manager, an object manager, and an object employee. We'll keep the pay rate same. So let's say we're calculating 100 hours of work or just 10 hours of work. And same for the employee. So running this, we should expect things to work as we wrote, basically. The employee gets, okay, the manager gets 2,000, the employee gets 1,000. That's how it should be. Both pay rate is 100. They work for 10 hours. That's 1,000, but the manager gets an extra 1,000 regardless of how many hours they worked. And everything works so far. Any questions up to this point? If I'm moving too fast, let me know. But so far, everything like should start getting familiar to it. Okay. I think there's no questions. Okay, so now let's try to do this. If we do employee, let's say base, let's call it base, and put it equal to manager. What happens here? So this is a manager, and we're making it equal to an employee object. Let's say we want to output the pay of this employee, which is essentially, it was a manager, and we did a cast here to an employee. The output is 1,000. It is not 2,000. What happened here is that we there was a downcasting here from type manager to type employee, and we lost some stuff as well. Like if you had any extra information in manager, we would have lost that information. Looking at the base object here, it has the type employee and not the type manager. And in here, there was an implicit cast between manager object and employee object. So let's ask this question differently. Like before we move into polymorphism, let's see, like let's have an application in which we would want to use polymorphism before we talk about what it is. Let's say I want to have an array. Let's say I have a class, I don't know, business. Okay, and this class has an array of employees. And let's say I have other classes, not just employee and manager. I have part-time employee, full-time employee, support staff, etc., etc. Many classes that inherit from employee. And maybe there's also a bigger hierarchy of stuff. Like under full-time, there's multiple classes that inherit from it. Under part-time, there's multiple classes that inherit from it, and so on. Is there a way I can store all of them in one array and be able to, whenever I call get pay, for example, it will handle things the way it should based on that type? Like this is what I would want to have. I would want to have employee here, employees, and regardless of what I store in it, okay, it's telling us, let's just add a default constructor for employee, and then we'll because an array has to construct all the objects at the beginning. Actually, in here, it's missing the size. Okay, so never mind. Sometimes, like you can, if I do, let me just. Okay. I think we have, you've covered like some stuff like that with the default and deleting things, but we'll cover them later. Anyway, forget everything I just said for the past minute. So we have an array here of employee inside the class business that has size 100. It's called employees. So our goal is, let's say we want to add an employee. Add employee, which will, what I'm going to use a vector because we just did an example on employee on arrays. So maybe we just do an example of vector just to remind you of vectors as well. So this is a vector of type employee. It's called employees. Now to add an employee in here, it will be simpler than having an array. Let's pass an employee by reference, constant reference. And what we're going to do, employees dot push back. We're going to push back to this array, to this vector, this employee. So now we have a new employee added to our vector. And let's say I want to print all print pay for from all the employees. So for int I equal to 0, I less than employees dot size I plus plus. I'm going to see out uh, employees at I dot get pay and add a new line. So in short, in my business class, I have a vector. So all of this is private so far. Let's make it public to simplify things. In my business class, I have a member of my business class, a vector of employee type. It's called employees. I have a function to add employees. It pushes back to this vector. And I have a function to print all the pay of all the employees. Okay, let's say get pay for 10 hours, because get pay takes a parameter. The print pay is going through every employee, and it's printing for this employee what's the pay for 10 hours of work, and so on. Now I will create a, actually, let's keep the manager and the employee. I will create a business object. And business.push.add employee, and I'm going to add the manager that we created. So the first element will be the manager that we created, and then the second element will be the employee that we've created. And now I want to print the pay. So what I would like to happen is that whenever in here the function is calling employee get pay, it will handle the first element as if it's a manager and the second element as if it's an employee. But we will see that this is not what's going to happen. So in our case, it handled both as if they are employees. It printed 1,000 for each one. If the first one was treated as a manager, it should have printed 2,000 based on what we defined pay rate for the manager. And the reason this is happening is because, similar to how we saw the downcasting before, this is exactly happening here. Whenever we push back an employee, the vector has the type employee. So it's going to cast whatever we pass here to an employee, and we'll be storing an employee, not a manager. So how can we solve that? Like, we would like to have this be treated differently. Now, even if we're dealing with pointers, with polymorphism, like and with virtual functions, which you should have covered by now, which we will gonna go into it right now as a solution to this. You're usually dealing with pointers. This is like runtime polymorphism, in which the compiler at runtime will be choosing which function to use. So let's say we create a pointer to employee. We have here a pointer to employee, and we're going to take the address of manager. So we're using this character to take the address of manager, and we're storing it inside the employee pointer. If we do pointer get pay, one failed, what's the error? Business undeclared identifier, okay. So what I did here is that I created a pointer of type employee, and then I pointed this pointer to the address of the manager object that we created here. And then I called get pay on the pointer. So use the arrow to access the object pointed to by this pointer, and we called get pay with also 10 hours. The output is still 1,000. So it is still treating this object as an employee object and not a manager object. Although in here we are pointing to an object. But why is that? Like it will always take this type, the base class, as employee. It's not reading the manager. To solve that, there's something called virtual functions, in which it tells the like on runtime. So let's see it working. So we're going to declare that this function getPay is a virtual function. Whenever you have a virtual function in the base class, it means it's virtual in every other derived class, but it's usually a good practice to rewrite it just to remind everyone that it's also virtual. So our function getPay now is virtual function, which means the compiler, whenever we're accessing it like this, like right here, we didn't do a downcasting. Our employee is a pointer, it's pointing to a manager object. But when we call getPay, it's going to use the type of the pointer to access the getPay function. So getPay will be the employee getPay. We changed the function getPay to be virtual function. And now the getPay that is being accessed is actually the manager and not the employee anymore. We can see the output 2000. The reason for that is that a virtual function means that the compiler, not the compiler, on runtime, the program will be deciding which function to make a call to. As long as they are virtual, it will be using the like the closest scope for its type. So in this case, it's a manager. There's a definition of getPay here that is different than the base class, and it's going to use this one. If we don't define here getPay, it's going to use the employee getPay. But the reason we are able to do this, now it's making a call to the manager getPay and not the employee, is because it's a virtual function. Before it was virtual, it was just making a call to the type of the pointer. So now going back to our business example, first thing we're going to change is that we're going to be storing pointers to employee and not employee directly. And whenever we whenever we are adding a new employee, we are okay. This is a bit advanced example. We can do it afterwards. Did you guys cover making a cast to the base class? I don't like, okay, we're just gonna cover it afterwards. So the problem we're facing right now is that if like right now employee, if we make it a pointer here, we are storing pointers of employee and we have this employees and we want to push back. What we're passing here is a constant reference. So let's make it a pointer instead of a reference. So let's pass, like let's just make a really bad design and okay. So basically our vector is employee pointer, has a type employee pointer. And whatever we are adding to employee, we're passing employee pointer as well, and we're just adding the pointer to the vector. So we'll run the example below, but before we need to fix this print pay now. Whenever we're accessing the array of employees, employees now hold pointers to employee objects and not objects of employees. So employees at I, we need to use the arrow because it's a pointer to an employee object. And now we're calling getPay. So because we are storing pointers of employee, and this is a pointer of employee, whenever we call get pay, it's going to follow the polymorphism of the inheritance we have, in which it's going, if the object that we're pointing to is of type manager, is going to access this get pay function. If the pointer of type employee, or the object being pointed to is of type employee, is going to access this get pay function. If we run this example again, so I'm passing the addresses of these objects like as by reference, which would give us a, like, it can, the address of these objects can be stored in pointers, although it's not the good practice, because if these go out of scope, then we lose, like, they will get popped out of the stack, and these pointers now will be pointing to like garbage memory. But it's good enough for this example. We're gonna rewrite this with a better way with dealing with pointers. But let's just test this. We have a business object. We've added the employee manager. We've added the employee to the business. And now we're printing the pay. Before we had an output of 1,000 and 1,000. Now by using pointers, it's treating every object. We're having another print somewhere. Yeah. Now it's treating every object, like it's calling the get pay depending on the type of the object or the class that it comes from. So the manager is, the first object is calling the get pay of the manager, which outputs 2,000. The second object is an employee class, which outputs 1,000. Okay. Just ask me your questions, because I know I'm like, it's maybe too much information, or maybe it's not, I don't know. Anyone have any questions? Okay. So what's bad about passing an pointer like this to add employee function and just storing that pointer as is? Like this would be an extremely bad design. The reason behind that is that, like, who owns this pointer now? This pointer, let's say we didn't do this. Let's say we've allocated new memory. So let's say we have a manager pointer, call it a man ptr equal new manager, and we've constructed a new manager on the heap. Same for employee. We've constructed a new employee on the heap. And then so in here, we've constructed a new a manager on the heap, stored with, like, pointed to by manager pointer, and new employee on the heap, which is pointed to by EMP pointer. And we've added these both pointers to, we passed them to the add employee function, which basically took the pointers as is and just added it to the vector. So now the vector, and so in other words, I'm going to add a breaking point here, and then I'm going to change, I'm going to access the manager pointer. Okay, we have the pay as private. Let's add a public function set pay rate. Just a simple set function. So I'm going to change this manager pointer here. I'm going to access whatever it's pointing to, and I'm going to change the pay rate. Okay. So our breaking point stopped here. Let's look at our business. So our business has an object, has a vector of employees. The first element is our manager. It has a pay rate of 100. Our manager pointer is the same pointer that is pointed to by that element, and it has a pay rate of 100. If I step over this line, now the manager pointer is pointing to an element, an object of a type manager that has a pay rate of 1,000. And the object inside the business, inside employees array or vector, which is the first element, also changed the pay rate to 1,000. Because we're dealing with pointers here. Both of those pointers are pointing to the same object that was created here outside of the class business. So even worse than that, what stops us from doing delete manager pointer? If we do this delete manager pointer, and then we call print pay on business, the business has no idea that one of its employees, the pointer pointing to one of its employees, was deleted. Like the pointer will still be there, but what it's pointing to has been deleted. Because we basically have access to it from outside the class. We're getting a crash now. It's saying exception thrown, access violation, reading location. It's trying to access that location, wherever this is pointing to, but it's getting an access violation. The reason for that is that we actually deleted that object. We deleted this manager pointer right here. But the business class had, or object of business had absolutely no idea. When you're dealing with pointers, it's a good design principle in that you have an owner for that pointer. Whenever you're allocating memory on the heap, someone must own that pointer. Whoever allocated that memory should be responsible of deleting it afterwards. No one outside that owner should get access to it. So how do we solve this problem right here? We can solve this problem by, instead of storing the pointers just as is, we can make a copy of them and just store a new employee object, store a new copy, instead of storing the raw pointer. So in our business class, we will be responsible of creating a new object, and then in the destructor, we will be responsible of deleting okay, let me keep it simple. We are responsible of deleting the employees. and no one from outside our business class has access to those row pointers anymore. They cannot delete our pointers. They cannot change the content of it. We, like the business object, owns those pointers. Okay, of course, we didn't change that yet. So let's see how we can change that. Is everyone following up so far? Like, just confirm by saying yes. Okay, good. If you have any questions, just let me know. So first thing I'm going to change is, instead of passing employee pointer to add employee, it's going to be, it can say employee pointer, but just let's make it a constant. Okay, do you guys know the difference between constant pointer and constant? Okay. So let's look at an example. Okay, so you can have a constant pointer and constant of whatever is being pointed to. So looking at this example, for example, constant integer pointer constant PTR. This is, PTR is a constant pointer to a constant integer, which means that having a constant pointer means that you cannot change that pointer. You cannot change the address that this pointer is pointing to, but it doesn't say anything about modifying what it's pointed to, like modifying that integer or modifying that object. But in this case, we have a constant pointer. It means we cannot change the address of this pointer. It's pointing to a constant integer, which means that that integer is also constant. In the second example here, we have constant integer pointer, PTR. This constant is for the integer, which means it's a pointer. A PTR is a pointer to integer constant. The pointer itself is not constant. So in this case, you are allowed to modify what this PTR is pointing to, as long as it has the same type, like constant integer. So it can start pointing to a completely different constant integer. In this example, it's the same thing. Whether we put integer constant or constant integer, it's exactly the same. So pointer is, PTR is a pointer to constant integer. If we replace these, it's the same. Now, the difference is if we put constant after the pointer. Now, in the last example, this is PTR is a constant pointer to an integer. It means the pointer is constant, but the integer is not. So we can access this pointer and modify the integer. But what we cannot do is change what this pointer is pointing to. There is a C gibberish part here. Let's see, constant. Syntax error. Okay, for some reason when I write PTR, it's taking it as syntax error. I don't know why, but it's a nice C gibberish to English. So this is declare P as pointer to constant integer. If we add a constant here, declare P as constant pointer to constant integer. So if you're like, if you're ever in doubt and you want to like translate your gibberish C++ to English, like refer to this site. Okay, going back to here, we're going to make this employee, we're going to pass this as constant employee, like constant pointer pointing to a constant employee. Okay. The reason we can't do this is because, so and anyone can guess why we're not allowed to do this? The vector here is storing employee pointers, like raw employee pointers. So what we are passing to add employee function is a constant pointer to a constant employee object. So it cannot copy it to this vector because this vector is not storing constant employee objects. It is storing just employee pointer object. Like if I make this constant objects, then we will be able to store it because now we are storing a constant object. We're not allowed to modify it anymore. But that's not what we want. We want to pass it as constant because we don't want this function to be able to modify what we're passing from outside. And we want to create a new employee object right here and store it inside our employee class. Now, if I do this, okay. So if I do this, now what's happening here is that I'm creating a new employee object. I am dereferencing the pointer employee that is being passed here to this add employee function. And I am adding to my employees vector a pointer pointing to a new employee object that I just created. Now, if everyone understood what we just did here, do you think it will work? Let's test it and find out. We have our business object. We are adding these pointers to manager and employee. So what should happen now is that we are going to create a new object of this and a new copy of this, and we're going to store it inside the business vector. So if we change the manager here, manager PTR pay rate, it will not change the employee that is stored inside our business employee vector because we made a copy of it and we're not storing the raw pointer. And now we're going to print the pay. We should expect to have 2,000 and 1,000. But that's not what we get. We get 1,000 and 1,000. So both of our objects now are being treated as employee and not manager and employee or whatever we store to them. Any guess why? Because that's exactly what we are constructing here. We are constructing a new employee object. If this employee pointer was pointing to a manager object, we are still casting it to an employee, not a manager. So it's our fault, really. We are assuming all of them are employee, and we are creating employee here. If this was manager, we shouldn't be allowed to do it. Yes, we cannot do it because we cannot construct a manager object from an employee object with an implicit cast like this. But we can cast an employee, a manager object to an employee object. We will just be like losing some of the information that's added to a manager, and we're just left out with the employee object. But we can do that cast, and this is exactly what we're doing here. So what we would like to do here is be able to check if our EMP is a manager object, then create a new manager object, or do a cast here to, let's, if it's not, add an employee object. So how do we do that? So there's something called dynamic cast. There's actually multiple cast functions in the standard library. Let's look at some. So this is the CP reference. This is dynamic cast function. And dynamic cast is used to cast pointers and references to classes up or down or sideways within the inheritance hierarchy. So hierarchy is like if you're drawing the inheritance, derived, base class, derived. So you might have a sibling class, which is like both of them inherit from the same base class. That would be like sideways. So you can use dynamic cast to do that casting. The good thing about dynamic cast is that it is safe. What we mean by safe is that if it doesn't work, so if the cast is successful, dynamic cast returns a value of type new type, whatever this new type is. But if the cast fails and new type is a pointer type, it returns a null pointer of that type. Which means we can check whether this casting succeeded or failed. How is that helpful? Well, that's helpful in here if we do okay, they're calling it dynamic pointer cast. Okay, maybe it's not. Okay, so we're going to do dynamic cast of type manager pointer of employee. If this is equal to null pointer, why is this giving an error? Okay, the problem here is that we place this as constant. Like we cannot do dynamic cast as constant, as a constant pointer. Okay, so I just removed the constant to be able to do dynamic cast. So anyway, we're doing dynamic cast to a manager pointer. We're passing, like we're trying to cast this employee object to type manager pointer. If this is equal to null pointer, we're going to output object is not manager. Else object is manager. Just keeping it simple, just to test things out. I'm going to remove everything. So basically what we're doing here inside this add employee function, we are taking the employee pointer object, and we are trying to do a cast of this employee pointer to a manager pointer. If this employee pointer is pointing to a manager object, it means we will be able to do this cast, and this will return a manager pointer pointing to that object. But if the type of this object being pointed to by this EMP is employee and not manager, it means this cast will fail, because we cannot cast an employee to a manager, but we can cast a manager to a manager. And if this fails, it will return a null pointer. So if it fails, we're outputting object is not manager. And if it succeeded, we are outputting object is manager. Let's make sure we don't have any, let's make sure that it's actually working. So in here, we're adding two employees, or we're calling add employee function twice. Once we're passing a manager pointer object, and the second we are passing an employee pointer object, or a manager class and employee class. Actually, we can also do this. So this can be an employee pointer, and it can be equal to a new manager. An employee pointer can point to a manager object and can point to an employee object, because they are all derived from employee. So what we hope that will happen now is that this line, when we call this function, it will output that this is a manager, and when we call this function, it will output that this is not a manager. And this is exactly what happens. The first one outputs object is manager. The second one outputs object is not manager. So what did this tell us, basically? This gave us a way to check if this pointer is pointing to a manager or an employee object. Because there's no way really to know, because the type of it is an employee pointer, like the type of this pointer. We want to know what is the type of the object that is being pointed to. So we tried to make the cast dynamic cast. It is a safe way to cast pointers. If it succeeds, if it's able to cast it to a manager, it means that this is actually a manager object. Or it might be we don't have a big hierarchy right now, but it might be a derived object of manager. Like it might be able to cast it to a manager object, a manager pointer, because it's derived from manager. But for now, we only have manager and employee. But if we're not allowed to cast it to manager pointer in this case, this dynamic cast will return a null pointer, which will tell us that this is not a manager, this is an employee. So how does this help us? Our goal was here to, what we want to do is that inside the employee class, what we want to do is, inside the employees vector, we want to create a new employee object. like we want to make a copy of whatever employee we are passing here to store it inside this vector. We don't want to be dealing with the same object that was pointed to from outside our business class. We want to make a copy of it and we want to store that copy and we want to own that pointer. So we will be in control of creating it on the heap, and then we will be in control of deleting it from the heap at the end. But if we want to just create a new object, we don't know what's the type of it. So if we create them all as employee, as we saw before, now we are losing information. We don't want that. We want to create a new manager for those that are managers, and we want to create a new employee for those that are employees. And now we have a way to actually detect that. So even if I know that this is not an, so this, at this point here, if this is equal to a null pointer, it means that this is an employee. So I can do pushback new employee, and I can dereference this object that we are passing, and I can create a new employee right here, just like we were doing before, because I know this is an employee. But what about the manager? If I try to do the same thing here, but new manager, let's say, and I pass the reference of employee, this is not going to work, because all it sees right now is that EMP has the type employee. It doesn't know that it has a type manager. Like similar to how we discussed before, the difference between stack and heap, the runtime program does not have access to the heap to do all the checking that it wants. So it doesn't know what's inside the heap right now. So it will not allow us to do this. However, this dynamic cast, like what we read in the documentation, if it fails, it returns a null pointer. But if it succeeds, dynamic cast returns a value of type new type. So dynamic cast will return to us a pointer of that new, like whatever we did the cast for, in this case, manager pointer. It will return a pointer of type manager pointer, which is pointing to this same object, which will then allow us to do this. In other words, let's do the dynamic cast outside. So we're doing the dynamic cast outside, and we are storing the information inside this casted pointer. It's just a variable that I just created. It has an manager. It has a manager type. So this is actually a manager and not manager pointer. Oh, I think it should be. So it returns a value of type new type. If the cast fails and new type is a pointer type, it returns a null pointer of that type. If the cast fails and new type is a reference type, it throws an exception that matches a handler of type bad cast. The new type, pointer to complete class type, reference to complete class type, or pointer to optionally CV qualified void. Ignore the whatever there. So what we're dealing with is pointers. So it should return a pointer to complete class type if it succeeds. Which means what we have here is a manager pointer. I'm using auto here, but it can be manager pointer. Because if it succeeds, this is what's going to return, a manager pointer pointing to a casted, like this same object, but it's just casted to a manager pointer. If it fails, this variable here will have a null pointer. So instead of doing the checks on the casting directly, I'm going to do the check on casted pointer. If it's equal to null pointer, I'm going to do new employee and pass this employee. But if it is not null pointer, it means I have actually a value here that is like a correct value of the object being casted to a manager. And I'm going to use this value to create a new manager. Now I am allowed to do this because the type of this pointer now is manager. I already did the casting, and the type of it is not employee pointer anymore. It's a pointer to manager, which means I'm allowed to do new manager. And our vector has the type of employee. It's pointers of employee, which means employee pointers can point to a manager or an employee. Now let's run this example again. We're adding the employee, which is the manager. We're adding a second employee, which is the employee. And then we are printing pay, which is going into here and calling get pay on every object. If the object is a manager, it will call the get pay of manager get pay. If it's an employee, it will call the get pay of employee because of the polymorphism, because of our virtual functions. And let's hope everything works. And it's working. We have 2,000 and we have 1,000. The first element is a manager and the second element is an employee. And this business class is now owning every pointer it holds. Every pointer inside the employee that we are storing inside employees, it owns everything about it. It constructed it. It created this new employee or new manager, depending on the type. And whenever it's destructing, it deleted those objects. And this is a much safer way than what we were doing before, in which we were passing the row pointers as is, and then we are storing the row pointers as is inside our vector. Because anyone from outside now can access those pointers, anyone can delete those pointers, anyone can do anything with those pointers, and we will have no idea from within our business class. Any questions? I hope you guys are still following up. Did everyone understand what we're doing? Like, if you want me to repeat any part, let me know. You're saying too many things as you have too many questions, or what? Well, good thing I remembered to record this. Usually you get asked to use this dynamic cast in your assignment, and it's something similar to what we did right now. Like, dynamic cast is used to cast pointers to other types of pointers within the hierarchy of classes, like hierarchy of inheritance. And it's a safe way to do the casting. So this will allow us to basically do what we just did, which store employees' pointers or objects, store employee pointer, objects pointed to. Okay. This will allow us to store employees being pointed to by these employees' pointers, in which we are making copies of them to store them. And we're checking the type of these pointers. Did you guys cover pure virtual and abstract classes, or not yet? Anyone knows the material you've covered in the lectures? Based on the slides, everything is in one slide, so I don't know what he covered today and what he's covering on Wednesday. But we're going to keep the abstract classes and virtual, like pure virtual functions, till next tutorial. There's one more thing that we should mention, which is virtual destructors. Now, right now, our destructors are default destructors. Like we don't have any other memory. But let's say inside our manager here, we are creating whatever, some sort of integer pointer, okay? And inside the constructor of manager, we are doing to the integer pointer new int3. Okay, we are creating an array of size 3 of integers inside an integer, like being pointed to this integer pointer, which is a protected member of manager. Now, as long as we're doing a new, as long as we're allocating memory on the heap in the constructor, we need to destroy this memory or delete this memory in the destructor. So we're going to override the manager destructor, and we're going to delete the array at integer pointer. Now, to know what if we're actually deleting, I'm going to output here manager delete destruction, whatever. Okay. So this should be like straightforward. We have a member of our manager class, which is a pointer, integer pointer. In the constructor of the manager, we are allocating an array of size 3 of integer on the heap that is being pointed to by this pointer. And in the destructor of manager, we are deleting this memory. We are freeing the memory we've allocated on the heap. And we're also outputting that we are accessing the manager destructor. Now, going back to here, manager pointer is, I'm going to comment all of this, keep it very simple, and I'm going to put this inside. Actually, we don't even need to. So this is an employee pointer. I'm going to delete, like actually we had memory leak before because we weren't deleting them. I'm going to delete these two. What I'm expecting to happen is that manager, when I'm deleting this employee pointer that is pointing to a manager object, it's going to call the destructor of manager. And when I'm deleting the employee object as pointed to by this employee pointer, it's going to call the employee pointer. So I'm expecting to have the employee destructor. So I'm expecting to have one output of calling the manager destructor. But I don't have any output. The reason behind that is very similar to how the getPay function wasn't working. We had to define getPay to be virtual so that on runtime, the program was like now checking, okay, now this is a virtual function I'm accessing, so let me check what type I have and where I am in the scope to find out which getPay I need to access. Otherwise, it's going to access the getPay of whatever type of pointer it is. Destructor, same way. Right now, when it's deleting this object, it's going to use the type of employee to call the destructor of employee, which we haven't implemented, but there's a default one. But we can override it and just output just to see that's actually doing that call. We are seeing two employee destructors being called, which is not a good thing. The way to change that is by making a virtual destructor. So by having a virtual destructor, now because of polymorphism, regardless of the type of this pointer, now we have a virtual destructor. So on runtime, it's going to choose the destructor that's going to call based on what type of object we are pointing to. If we run this again, we're going to see manager destruction, employee destructor, employee destructor. So we are calling the manager destructor. Why are we seeing two outputs for employee destructor? You guys should know this answer. I'll simplify it even more. Let's only create a manager and delete a manager. We are seeing an output for the manager destructor and an output for an employee destructor. Anyone? When we're doing inheritance, we inherited everything of employee to the manager. So manager basically contains an object of employee. When the manager is getting destroyed, when we call the destructor of the manager, it's going to destroy the manager and then it's going to destroy that object of employee. So it's going to call that destructor of employee as well, because we're inheriting everything. So this is why by destroying only the manager, we're seeing two calls, one to the manager destructor at the beginning and then the employee destructor getting called. So always remember, if you have, like when you're having polymorphism, when you're having a design like this, destructors needs to be virtual, because you will have like undefined behavior where we have free, like you're having memory leak in this case. Like when we didn't have this virtual destructor, we are now having memory leaks because we have allocated an array of size 3 of integer on the heap, but we are never destroying it because we're only making a call to the employee destructor and not the manager destructor. By declaring that this is a virtual destructor, now things are like on runtime, it's choosing which function to call, which destructor to call based on the type of that object that we are pointing to. Okay, we're gonna stop here. If you have any questions, please let me know. If you don't have any questions, tell me no, just to know that you're here and watching and everything. Okay, we have 2 no's, 3, 4. Okay, that's good. Okay, I hope this was helpful and you understood what I was trying to cover. Next tutorial, we will do, we will discuss pure virtual functions and abstract classes. I'm stopping the recording now to share the attendance form.